Okay, so what's up, Curtis? Um, okay, so this is how I would think about this one. Here, let me get this. Okay, so first thing I thought about was all these are areas except for C. C is like some volume. I think that's definitely out of the question because there's no pies in this. If this was the volume that's of something rotated, um, there would be some kind of pie. If you'd have to either do wash or shell method, and either way there'd be a pie in there somewhere. So it can't be C. It's got to be one of these areas. And then part D, the Riemann, or answer choice D, the Riemann sum adds up, just in general. Actually, here, let's do the general thing. So that'll be, actually I'll use capital N just because he does in this one. And this is if he uses the right hand endpoint. So this is okay. Okay, so and yeah, so this is right. The idea is that you have all these rectangles, right? And so this is the width of each rectangle, b minus a over n, and then that's the same thing as this, right? And then this is the height of each rectangle. So I think it's not D because this height, in his problem, if we kind of look at it, this 3 over n looks like b minus a over n. So I would group those together, do like 3 over n here. So that looks like that's the width of each rectangle, each subinterval. And so you would get that by subtracting two things, right? So but anyway, but it doesn't look like it's D because the height would have to be two functions subtracted. You'd have an upper curve and a lower curve, and you'd be subtracting those to get the height. But this is just, in his problem, it looks like this is just a single function. Yeah. So if on the midterm, if he has, in this fraction, if he has two things subtracted, maybe that would be the area between two curves. Okay. Yeah. So I would eliminate D. Okay. So it's all the rest are just areas. All these are just areas between x-axis and the curve, from different starting points and ending points. So this is from 2 to 5, this is from 0 to 3, and this is from 2 to 3. And the way I see it is, it can't be from, if here, I'll rewrite his thing real quick. So if we rewrite what he has, but kind of lining it up with this, or kind of relating it back to this. So his function would be like sine squared of e to the 2 plus That's one thing. When you have this expression, I think just the 3k is divided by n. You were dividing that whole 2 plus 3k divided by n. So I think it's, yeah, just the 3's divided by n. Oops. Okay, so that's what he has, and then you could kind of write it like this. Times 3 over n. So that's the same thing that he has, basically. Okay, so we can see like this, whatever here, this 2 plus 3n is what you're plugging into. It looks like what you're plugging into some function. You'd be plugging into sine squared of e to the x, 2 plus 3n. And that, that's all the functions that's given here. So, except for this 3, but, okay, so this is how I would think about it. This a, is whatever's added that you're plugging into the function. So that looks like that's 2, right? So if a is 2, that means it's going to go from x equals 2 to something. So that like eliminates b. That b starts from 0. And then b minus a, and so really this is a. Really, a equals 2. That's the starting point. So yeah. So really a equals 2. And then if the if you have a 3 here, if you have a 3 here, then b minus a is 3, and if a is 2, then b has to be 5. Right? So that you get, b minus a is 3. And so, so that kind of shows that this is e, right? Since that goes from 2 to 5. And it eliminates this. Yeah, you can kind of just see everything kind of lines up. This b minus a over n is 1 over n, is oh, there should be a k here. Yeah, that b minus a over n is 3 over n, and you can see that's this 3 over n here, and times k. And then, and then b minus a over n again is 3 over n. Yeah, so this is what I would do. Like if you get this on the midterm, look at like whatever looks like it's being plugged into the function, 2 plus 3k over n for this one. Think of the thing that's being added. Think of that as a, the starting point, from the interval that you're trying to find the area of. So that's a. And then whatever is multiplied by k over n, whatever number, that's the width. So if it starts at, a is where it starts. And if the length is 3, it's got to go from 2 to 5, and so that gets you the limits at least. Yeah, and then the rest, I guess you just kind of have to figure out if it ended up being a volume, you'd see a pi in there. And if it ended up being kind of the area between two curves, you'd see two functions subtracted. Yeah, so this one has to be e. Okay, so this is the that fundamental theorem of calculus that we were doing. Okay, so the only thing you do with this, if you're taking the derivative of an integral, so yeah, I mean, just in general, all you're going to do is take the upper limit, plug it in to the function, and then times that by the derivative of the limit, and then do minus, plug in the lower limit into the function, and then minus, take and then multiply it by the derivative of that limit. That's what you're going to do in general for all these. So if we do that for this one, this would be 1 over, and then so just plug sine in there. It'll be sine to the fourth x plus t, and then just times that by the derivative of the limit, derivative sine, which is cosine, minus, and then plug in x squared, you get x to the 8th, and then times that by that derivative x squared, and that's it. So these are nice. All these are about substituting limits and multiplying them by, each one of those by the derivatives. That should be 1. Oops. Yeah, I think that would be the final answer. Yeah, so just about substituting times by derivative minus substitute times by derivative.